EPA's Clean Power Plan rule requires that states develop plans to reduce carbon dioxide emissions from power plants. Emission limits are assigned using either a rate-based or mass-based compliance pathway. In this video, we'll look at both rate and mass-based emission standards. We'll see how energy efficiency and clean power generation act to reduce CO2 emissions. We'll also demonstrate an important concept called leakage. First, let's examine the rate-based pathway. Rate-based approaches limit the pounds of CO2 emitted by power plants per megawatt hour of electricity generated. States may choose a single statewide emission rate goal or may choose separate rate requirements for combined cycle and fossil steam units. Here we are looking at the statewide goal and an example of a glide path where the allowable emission rates are stepped down over 3 interim compliance periods. Regulatory limits are represented by red dashed lines. Total annual emissions from power plants are shown by the stacked bars, with coal sources in gray and natural gas sources in blue. As each year the simulation solves, JuiceBox estimates power plant operation and emissions from each facility within a regional multi-state power grid. Planning assumptions are made for this state as well as neighboring states seeking to meet new emission standards. The blue dashed line represents the average power plant emissions. If the blue line falls below the red line, then the projected emissions are below the regulatory limits for the state as a whole. But compliance is determined for each affected power plant based on its individual emission rate. To meet the declining emission standards in the rate-based approach, the regulated power plant source must acquire emission rate credits, or ERCs. An ERC represents 1 megawatt hour of electricity from a new non-emitting generation source. Along the timeline are simulated additions of new energy efficiency and renewable resources. These investments are producing ERCs and are being counted towards gas and coal power plants to lower their effective emission rate. In addition, heat rate improvements are directly improving efficiency and lowering emission rates at some sources. The end result in this scenario is that the combined effect of these emission reduction measures were sufficient to comply with the emission standards for the state as a whole. Next, let's look at the mass-based approach. A mass-based approach limits the total allowable CO2 emissions from affected sources. Each power plant source must acquire allowances representing 1 ton of permitted CO2 emission. Here we see the glide path for the same state using a mass-based compliance pathway. In 2024, emissions from affected sources drop just slightly as a new combined cycle natural gas unit comes online. The new gas unit is not regulated under the Clean Power Plan, and its output is acting to reduce emissions from affected sources. Shifting of emissions from affected sources to non-affected sources is termed leakage and requires contingency measures by the state. One possibility is for states to choose a pathway with what's termed the new source complement. The new source complement affords the state slightly higher emission limits, but requires that new fossil fuel resources also count their emissions toward those limits. In this example, the additional emissions from the combined cycle unit are much greater than the additional allowances afforded under the new source complement. In this case, the complement pathway would require further emission reductions and would also achieve a lower overall CO2 emission profile for the state. In this video, we've seen that states choose between rate and mass-based compliance pathways for the Clean Power Plan. We've seen that future construction of fossil fuel power plants may result in leakage. We've also seen how heat rate improvements, energy efficiency, and clean generation act to reduce CO2 emission rates, though as we see here, the total mass of CO2 emissions could still increase under a rate-based approach.